There's no real set of rules for integration, but integrating fractions, it's probably going to be one of these 5, so at least this might give you a handle on the options to think through before you start panicking. So there's 2 basic ones, which you've already seen. One is where you've got something over something, and the bottom bit is just multiples of x and things added on. Doesn't even matter what's on the top. That's one example of a basic one. That's come from learn. So originally it was learn 3x plus 1, and then you think, what would happen if I differentiated that? So if you differentiate learn, you get 1 over, so you get 1 over 3x plus 1. Then you'd multiply by the derivative of the inside, the derivative of the baby, which is 3. We don't want that there, so we put an over 3, and then there's a 4 on the top, which we need to put in, and then plus c. Another type of basic one is where you've got exactly the same thing, but it's squared or cubed or to the 3 or 4 or whatever. So if I write that a different way, you should be able to see what we're going to do with that one. That is basic because it's one of the 9, just like the 4 over 3x plus 1, because it's come from 3x plus 1 to the 3. So, thinking through, what would happen if we differentiated that? The 3 would come down, so we better give that a third to land on. Then we would change to a 2, correct. Then we would multiply by the derivative of the inside, which is 3. We don't want that, so we put another third, and then there's a 4 there which we need to put in, plus c. So it's just thinking it through backwards. The other one that is our basic one is our spot the dog one, where we spot the derivative. So anything where you see something down here and then its derivative on the top, x squared. Doesn't have to be the exact right amount because we can change it. Say we made that plus x, and then this was, oh, now I'm going to have to actually think. Okay, let's make life easy for myself and put the actual derivative on the top. So when you see that, anything that's like f of x down the bottom and f prime of x on the top, that's come from, what's been differentiated is learn. So in our case, what's been differentiated was learn of 4x cubed plus x. And if we think through what would happen if we differentiated that, well, we'd get 1 over 4x cubed plus x, which is good, and then we would multiply by the derivative of 4x cubed plus x, which is 12x squared plus 1, which is on the top, so that's good as well. So that's done, it doesn't need any adjustment, it just needs the plus c. Okay, so there you get nice easy ones. Let's just move that out of the way a minute. And then we've got these more difficult ones, but again, they're not that difficult. Basically, you've got your algebraic division and your scary, big, horrible fraction, which is fine because you can break it up using partial fractions. So the difference between these two is how heavy the top is. So if the top is heavier or the same, so like x cubed plus 3x squared plus 1 over x squared x plus 2, the highest power on the top there is a 3. And the highest power on the bottom is also a 3, because if you expanded this out, you get a 3. So this one isn't top heavy, but it is not bottom heavy, which is what we use algebraic division for. So if I change that 3 to a 4 or a 5 or a 6, it's obviously top heavy. But even with the 3, it still needs the algebraic division to pull it apart. So we'd go with the algebraic division first, and we'd write integral. I haven't actually done this, and I just made it up. So I'm just going to literally pretend, okay? Say it comes out as 1 plus x squared plus 1 over x squared x plus 2. I am totally making this up here, but roughly it'll be that sort of shape. So what we've now got is something we can integrate, and then something here which we can use partial fractions on. So this bit here that's come out is actually a big scary fraction, but because the bottom is factorised, or can be factorised, or is factorised in this case, we can pull it apart using partial fractions, and then everything breaks down nicely and it all becomes integratable. So final one, big scary fraction, that's where you've got stuff on the top and you've got stuff on the bottom, but the stuff on the bottom has either already been factorised for you or you can factorise it. And recognising that even though it's a big scary fraction, it can be broken up into its partial fractions, x minus 1, x minus 1 squared, and x plus 1 dx. with don't know there and don't know there and don't know there, but you know the partial fractions method, so you can work it out. And then this one, well, that's basic coming from ln. This one, basic coming from x minus 1 to the minus 1 to the minus, I had to think there. That one is x minus 1 to the minus 2. So it must have come from x minus 1 to the minus 1. And then that one on the end, again, is the basic one, that's just ln. So all of these are part of your 9. So they're nice and easy to integrate. That's part of your 9. This isn't, but then this brings you on to the partial fractions, which then gives you ones from the 9.